Bonjour à tous et bienvenue dans le Cloud Screener, le podcast qui navigue parmi les nuages. Nous sommes comme d'habitude avec mon Houdini de la communication, Monsieur Jérôme Blin.
Bonjour à
Bonjour.
tous. Salut.
Et nous sommes aussi avec beaucoup d'invités aujourd'hui, beaucoup, trois, ça dépend si trois c'est beaucoup pour vous, mais on est tout d'abord avec Sean Brown de Rising Cloud. Hello Sean.
Good
Et
morning,
avec,
everyone.
et avec Clay aussi de Rising Cloud aussi.
Hello.
Et Rohit de Tumeryk. Hi Rohit.
Hi, how's it going?
Fine, fine. Et comme vous l'avez capté, nos invités sont pas francophones, mais moi je travaille chez Claude Mercato. Ainsi, la barrière de la langue va être aisément franchie aujourd'hui. Et on va switcher en anglais pour dialoguer avec eux, excusez-moi. Et j'espère que vous capterez tout autant que moi. Moi, je pense que je capte à peu près à 80%. Et bon, peut-être vous plus, j'espère, hein. On va voir ça. And so, we are in the cloud screener. I already presented you plenty of profiles from different kind of companies, integrator, SaaS, FinOps, cloud vendor, IaaS, PaaS, really a lot of profile. And today, back to the roots, I would like to introduce you a cloud provider. Not a common one, the kind you might not have thought exist. I call Rising Cloud. So why I am so dithyrambic? Rising Cloud is a public FaaS vendor. FaaS like a functional service, like serverless, like AWS Lambda if you want. And they focused just on that and deliver a unique service. Basically, you know what is SaaS, you know what is serverless. It's not the major part of the cloud computing, but maybe in the future it will be. For today, if you would like to set up a function, you go on one of the hyperscaler, because generally there is only FaaS on the major cloud provider. You choose an adequate flavor for your requirements. So 2 CPU, 8 gig, 4 CPU, 8 gigs or 16 gigs, depend of what you need. You enter in L for the setup of your function, depending of the cloud provider, of course. And next, you are able to run it. This is the schema for the major part of the cloud provider. Now let's talk about Rising Cloud. At Rising Cloud, firstly, you come and their flexible compute lets you choose the best fit for your function. So it's not about static flavor, static serverless, if I can call it like this. Here, if your function requires 1 CPU and 16 gigs of RAM, or let's make the reverse, 16 CPU and 1 gig of RAM, you can have it, no problem. You just set up it, you will have it. For the second step, you even don't have the key to the Inferno because it's simple to set up a function at Rising Cloud. And for the third step, you run it, but at a lower price. And I would add one more thing. If you would like to skip the first step, just use their AI. They have an AI that will automatically make the resource match with your function. So maybe you write a function and you don't know how much it's needed in terms of CPU, how much it's needed in terms of RAM, or maybe one day your function will need 2 gigabytes and the next day it will require only 1 gigabyte. Let the AI do it for you. No worries. It's not about you get to think each day about how to make FinOps on your function. Rising Cloud do it for you. We'll talk more about this AI system during this interview because we have Sean, we have Clay, which is, if I understand well, the brain that created this project. But for now, before to start the interview, I just would like to ask, did I give a good description of your service?
You did perfect, Anthony. Absolutely. Yeah, we really appreciate you having us on. It's a pleasure to speak to your audience again. So yeah, we appreciate all that you do, and you did a perfect job describing exactly what we do, making a developer's life easier. And that's a lot about what we're going to be talking about today, is how we're extending that further to provide more capabilities wrapped around that AI use case that people are building on us, including partnerships with companies like Tumeryk, which Rohit will talk about here in a second. So yeah, great job. Spot on. Appreciate it.
Cool. Nice, nice. I'm not wrong because maybe I should say something that is not the exact reality, but we are on the same frequency. That's cool. So, in a short, could you present me who is Rising Cloud, where you are, who you are, when did you start, etc.?
Absolutely. So the technology has been around for a little bit over 4 years now, I want to say. The technology is been used in-house by some of our closest technology vendors like Stacks and Multis Medical, specifically for their own use case. And then about 3 years ago, we decided to take it from what was an internal technology and turn it into a public SaaS solution for companies to also use and benefit from the same capabilities. So that same technology, we've just continued to expand and make easier to use and make more elastic as we've grown it out. So the technology itself is essentially a software stack that lives across a multi-vendor ecosystem. So we are a FaaS, as exactly as you said. One of the key differences is, though, we don't live in our own data centers. We actually scale out our customers' functions and workloads across a multi-vendor backend that they don't have to manage. So the beauty behind us is we actually give you multi-cloud without having to manage multi-cloud, just one of the little side notes. But part of that also is that we also provide the ability, as exactly you said, to dynamically scale everything, scaling the CPU, scaling the RAM, and even a little differentiation for, as you pointed out, comparing us to Lambda. We also do GPU, not scaling, but allow you to
Ooh,
do serverless functions with GPU. Exactly. Ooh, that's right. So those developers out there who are building serverless functions, building workloads that need to use a GPU, we provide the same ease of use as a function, but you can pull in a GPU to use that as well. So again, making it easier for people to build those custom, unique solutions to their unique problems on a platform that is not tied to my own data centers, but can scale out elastically across multiple vendors, reducing their overall costs while at the same time still keeping the developers' lives easy.
okay. So, and how much people have you in Rising Cloud?
We've got, I'd say, about a dozen-ish around the world. Most of our developers are based either in the US or Europe. And then obviously sales, go to market, finance, and things like that. But we really tried to keep it lean because, again, we're trying to keep our costs down for customers. So the more that we can automate, the lower we can keep our costs. And that is one thing that we do preach. This is not just someone talking about the Kool-Aid, but we actually do drink the Kool-Aid. The same types of algorithms that go into scaling our customers' applications actually scales our infrastructure. So the actual physical servers that are behind that
Okay.
get pulled in and out. Just to give you a little quick customer use case, basically since the last roughly week or so, we've had a customer that's been scaling up to almost 200 servers, but only for a few minutes, and then back down and scaling up and back down. Imagine if you had to do that, a DevOps person, that'd be the full-time job just doing that. We do it all automatically. Costs them about $30 a usage, nothing significant to them, nothing significant to us, but the system's all doing that for them, all automatically making their lives really easy, but still being able to support their end customer use case of reaching their customers and scaling out regardless of how many people are using it.
Okay. And so who comes to Rising Cloud? Who need to use Rising Cloud? I guess, of course, there are the people using AWS Lambda, but my first guess is people using Lambda don't imagine why they need
Mhm,
Rising Cloud.
mhm.
So
Yeah. Mhm,
who are the first wave of customers, the second wave, etc., the
mhm.
people that you have to convince to come to you?
Yep, absolutely. So definitely our first wave of customers have been your AI companies that are building custom AI solutions. So I talked about Stacks and Multis. Stacks, for your audience's perspective, they're a company that's kind of like Dropbox meets IBM Watson. So it's the ability to ingest structured and unstructured documents, but then allow a user to do a search through those documents and find the information they need quickly. All of the AI processes that are behind all of those algorithms, those are all running on Rising Cloud, so that Stacks doesn't have to guess at what they need tomorrow for number of servers or number of instances. They just let Rising Cloud scale dynamically up and down for those workloads. And then in the medical space, we have Multis Medical. They do completely different. They take MRI files, like an MRI of your neck or your shoulder, and they use the AI that's running on Rising Cloud to create an animation of that. So you can see what's going on in your neck or what's going on in your arm or your shoulder and things like that. Those are the kind of first adopters that were quick to realize the value of Rising Cloud, because their development team is really, really advanced and specialized in what they do. And they don't necessarily want to have to learn a cloud platform on top of knowing how to animate MRIs, for example. And so that's where Rising Cloud is a perfect fit initially for, is those kind of companies who they know what they want to do. They're very specialized, they're very unique in their market, and they need a cloud platform that doesn't burden them with having to learn a cloud platform. They just want to run their code and focus on running their cloud and focusing on making their applications quick. Now, the next wave we see is what's going into next year is people who want to then start using some of the existing models. So going from just the custom solutions, but maybe bringing in some of the existing models. And that's what Clay and Rohit come into the conversation. So Clay's building this workflow and framework around how you can point to a model that you need, how you can bring in your data sets and point to your weights and simply run that for you in a custom solution that can still dynamically scale like we talked about to keep your costs down, but at the same time, being able to have complete control and governance over that data, even so much so as even behind your own firewall. So we are a cloud platform, or actually a unique cloud platform that let you install it into wherever you want. So if you want to put our cloud on your servers behind your firewall in your data center, we can support that. If you want to install us inside of your public cloud, for example, so you want us running in an environment that you have a contract for, we'll also be able to support that into the new year. So we're a unique solution that kind of bridges that hybrid cloud use case, while at the same time still being able to provide the benefits of the hyperscalers by being able to keep your costs down and things like that. So that's where I see the second wave, is people who are starting to adopt more and more of the models out there, but for all sorts of different use cases. Sure, that the LLMs, they've gathered the news in your OpenAI, and they did a great job. I don't know whether it was really for generating news or not, but they've been in the news plenty lately. But we think there's more than just large language models that can be run in AI. And we know they're out there, and that's really where that second wave is going to come. People who are building custom AI applications, maybe using the public models and want to be able to just consume them, point to them, but then, for example, bring Tumeryk in and control that governance around it. So you might be using an LLM, but you want to know who's getting access to that data. Where is that data being presented? Is somebody maliciously trying to use that data? So adding other solutions around that is where we see then that second wave needing us to advance our platform. And we know we specialize in the fast, but there are a lot of vendors out there like Tumeryk, for example, who could bring those other things that the developers are going to need into the equation. And so that's where we see taking our development roadmap is enhancing that as well. So yeah, long-winded answer to that's kind of where our second wave is. And the third wave, we'll see. That's only the future can tell.
Yeah, for sure. So you just mentioned it, and so I would like to give you the microphone. Before to ask what is your business and more, I would like to know what is your link with Rising Cloud.
So as Sean mentioned, right, as the applications for AI are expanding and coming on the cloud, the risks from the applications, the AI applications, is increasing as well for the people using them, because there are some well-known AI cyber risks. These are called adversarial AI attacks. So for people who are using sensitive data in their AI models or using AI for sensitive use cases, they want to make sure that their models are well protected. And there are attacks that can be run against AI models, such as evasion attack, which essentially means you can evade or bypass the prediction the model was going to make just by sending it some data that has been manipulated. And by doing so, the cyber criminal can get a response back that is favorable to them. As an example, in the United States, we use a system called ID.me, which is used in California and many other parts of the country to verify your identity. And someone was able to bypass the ID.me image verification system, where they use the driver's license to verify, to get up to $3.8 million in unemployment claims. Obviously, he didn't make that much money to get that much unemployment, but over 15 months, they were unnoticed that they were actually doing this, right? So there are lots of risks that in AI, people are unaware that there are these risks. So not only can you bypass the model, you can also steal data from these models. You can, so training data of models is sensitive. And if the attacker can steal that data, they might get some personal information out of it. Yesterday, Google Research just announced a paper in which they showed if you keep asking a large language model to repeat the word poem, and it will start divulging its training data, right? So these are just like, very simple things that anyone can do. And now you're able to attack this AI infrastructure. So as much as we want to encourage innovation, we also have to manage the risks. And so with Tumeryk, what we are working with Rising Cloud is to grow the adoption of the AI applications, but provide people with risk mitigation. Because, we know that it's great to develop models, but a lot of data science models never make it to production because there's unknown risks, and a lot of times there's regulation. And you in Europe know very well, right, that the AI Act is coming up. And in fact, I don't know if any progress was made today, but I think today is the day, and this happens to be December. So I know by the time listeners hear it, it might seem like it's dated, but we are still awaiting for what the EU AI Act will actually bring about. And so people have to not only be secure, they also have to be compliant. And so what we do is we provide what's now being referred to somewhat in jest, but I think this is becoming serious, what we call an AI nutritional label. And an AI nutritional label basically gives for you a quick understanding of what's in the AI model, what data was it trained on, what is its performance characteristic, is it fair, is it biased against a particular subgroup or category. And all of those are additional risks in AI that you essentially have to deal with. So think of the AI as both the embodiment of an artificial being, where there's some physical infrastructure to protect, but also the brain of a artificial being, which has to be protected so it can't be manipulated. And what we are doing at Tumeryk is essentially help people get that these AI models, it's not just about scanning your code and scanning your libraries. There's a lot more that's needed to protect these AI models.
Okay. From all what you said, I guess you made a large step forward, Sean, since our last conversation. Really large. So, Rising Cloud entered in the GPU market with all the things that we know nowadays, the LLM, the image generation, the text-to-speech. For me, it's really much with what you are doing. The only question was really about the hardware required to run this kind of workload. But if we go on the web, we look at the SaaS solution, the AI SaaS solution, everyone will say, okay, you launch a request, you get the response of what you want. The request could be ChatGPT, you ask a question. The request could be here an audio. Could you give me the text from this speech? Or it could be, could you create an image from this text? And this match perfectly with function as a service at the end. So yeah, a good step that you did in the GPU market. But what are the steps to transform your CPU platform into a GPU thing?
Yeah, absolutely. So, obviously first we had to do that hard lift of getting GPU integrated into a serverless platform. So being able to support bringing in a GPU. Now, obviously the serverless functions for CPU are still there. We still dynamically scale CPU and GPU because a lot of models actually can use CPU as well. There's some new ways of being able to process it, things like that, and those are still there, but some obviously can benefit from having a GPU. So hard lift of getting that in. Now, once we've got it in, we've had it in there for over 11 months now. Now we're taking that next step. We're going to make it easier for the developers in the build process and in the run process. And so Clay's actually got that roadmap and actually the burden of actually building it as well to actually make it so that customers can take what might be weeks of time to build, let's say a Llama 2 deployment and get it up and running to just a few minutes of time, being able to cut down that. So the developers, again, back to our mission, making developers more productive, more efficient, giving them time back to focus on what they're doing for their company that benefits them and differentiates them from their competitors. And so that's the same thing here. So being able to create that framework and that model to be able to just point to your models, point to your data sets, point to the security solution you want to add on top of that, add your weights in, and then hit go and let it run and let it do what it needs to do. Because at the end of the day, the cloud's just supposed to run that workload for you. You don't need to necessarily need to manage the cloud. It was supposed to manage itself. And that's what we're bringing back in the AI models is being able to still allow the cloud to just manage it for you instead of having to go out and rent a server, configure a server, secure that server, manage that server, then install your application on the server. And you get it.
And then after you install, after you train, after you did everything for your AI model, you still have all the risk that that Rohit just talked about. So
exactly.
clearly, you surround with the good company for making how to say that, to making a good service, a service that is how could we translate that, Jérôme? Fiable, reliable, exactly.
Trustful? Okay, reliable.
Yeah, to make a reliable service. To go back to you, Jérôme, uh, I know we are in English, so me too, my brain is burning, no problem on that. But there are all the technical words that we just said. We talk about fast, we talk about CPU, GPU, AI, LLM, and abstract things. Maybe you have a question to light up everything, to make it more clear for everyone.
Yes, I have some questions. I have one question for Rohit and one question for Sean. I will ask for Sean first. It's a very, how can I say? I am the less technical, because I'm not technical at all here, and I am more about marketing, the philosophy of companies, the spirits behind the product, etc., etc. And I saw that on your LinkedIn profile, you wrote a sentence from Steve Jobs. I will say in English, sorry for the real English speakers. The sentence is, it's a famous sentence. A lot of times people don't know what they want until you show it to them. How do you use this philosophy in Rising Cloud?
Absolutely. So I think that philosophy even goes back before Jobs. If you look at Henry Ford, if you'd asked a person what they wanted, they'd have just said faster horse. They wouldn't have said the car. At the end of the day, we as humans know what we think we want, but it's hard to figure out what we actually need. And so, where I view that is bringing in designers. I have a strong belief that design team is a key component of that three-legged stool of product management, development, and design, all working together to be able to find solutions to problems. So, where that comes in is looking at the user experience. What are the problems and the pain points that users are experiencing today? If you look at Rising Cloud's history and what we've done so far, I would say 99% of the capabilities and features we have are about focusing on addressing problems that the current hyperscalers have. So just examples like being able to scale the RAM and CPU. None of the other hyperscalers do both. They make you pick how much RAM, and then they give you a quantity of CPU. We let you just run it. So, looking at those problems, other examples are running the types of runtimes you run. What are the base images they're using? Things like that. Being able to bring in whatever you want. I built an example kind of more of as a tribute to my father, who was a COBOL developer, but I have an example of a COBOL app running on Rising Cloud. That's what we wanted to be able to address. Again, focusing on pain point, trying to run your own custom unique thing on an existing hyperscaler, hard to do. Being able to figure out what you're going to need in terms of resources, hard to do. Addressed. And that's what we're doing with the AI piece, is being able to look into the future to see, okay, we know people are building custom applications that exist today, but there's now a lot more models that are being publicly available and adopted. But we think that people want to be able to point to the data sets and govern that security of that data set. And so being able to allow more of kind of moving up level or up stack, for example, to be able to consume those, but still in a secure, governed way that still keeps your costs down. So again, just how I do that, just look at the users. At the end of the day, anything we're building today is to help benefit humans at the end of the day, help you be able to do your job better, do your job easier, be able to get home quicker from work and not work on the weekends and not worry about things like that. At the end of the day, that's what I try to take into account. And a lot of it just comes back to design research, talking to customers, listening to what they have to say, doing market research, looking at what you're seeing from the white papers. A lot of the AI stuff also is unique from my previous lives in IBM, I would say, where a lot of it's more on kind of a unique flavor coming out of research organizations. So Clay's background, actually, he studied dark matter in college. I've never work with a developer before that was actually an aerospace person, and that's what a lot of the developers that we have coming up in the AI ranks today are coming from. They're not your traditional software developers. Plenty of them out there, obviously, and they're doing a great job too. But you've also got a new facet of developers that are coming up who are also equally brilliant, but coming from a different perspective on how to build things. And so blending together how you consume the cloud with how you need to use the cloud is a lot about what we're focusing on, and looking at the pain points that come from blending those two worlds together so that we can make a solution that's easier to use.
Okay. And I saw also that you have, actually, I guess everyone has a very long experience in the cloud, in the computing and everything, even security. Did your opinion, your view on the industry, on all this industry changed, and how did it change, if it changed?
Well, I mean, you're asking a broad question there for somebody who grew up. I like the Oregon Trail generation. We're not Gen X and we're not millennials. Like this generation of people who were before the iPhone, before the iPod, but also before the internet, but still also now, there's a lot that's changed. I mean, you can look at everything in the past 30 years, and it's amazing. I often think about my parents and grandparents, the things that changed from the early 1900s until now, and now the things that are changing. It seems like it's just as much change, but happening so much faster. And so being able to keep up with that change and keep ahead of it, looking at the analyst papers, looking at the market research, looking at what our competitors are doing as well, looking at where new vendors are innovating. It's amazing how fast technology is changing. Yet at the end of the day, it's still focused on the same thing, addressing problems. So what is the pain point that we have, and how can we make that pain point go away through technology and lessen the burden on users? And so, it is a pretty cool time to be living right now. I think there's a lot of opportunity out there. Obviously, with things that are being invented, it's amazing some of the smaller startups that come into to our pipeline to see what the cool things that they're building. Because obviously, we don't build a product, we build a platform. So all the things that are running on us are products at the end of the day, and it's just amazing the technology that's coming out and the things that'll be here in the next year, 2 years, 3 years. What those things are going to be able to do, and how they'll transform and revolutionize our lives.
Yes, it's funny because yesterday we were yesterday we were talking with the CEO of Mergify for another episode of the Cloud Screener, and we talked a lot about the problems and how to solve a problem in the computing, etc. And I asked what's his process to solve a problem in his company. He told me, he told us, sorry, he told us that he was focusing a lot on what his customers, prospect leads, were saying about some trials, about his product, or after a while using the product. Do you just rely just on the review of your customer or leads, or do you also use your experience as potential customers to solve some problem or to detect some problems?
Yeah, absolutely. It's a combination of all of the above. So obviously you're going to listen to your existing customers. You're going to listen to potential new customers, listen to customers that you lost too. It's not like you win every deal. And so you can still learn from those engagements, listening at peers, even conversations like, we have here. This is an opportunity to gain insight, to understand what people are dealing with and the struggles they have. Obviously I use every interaction I have in a day to try and understand what is working and what is not working, I'll just say, and how can we make it better? Because you're exactly as you said, you just have to be listening and not talking, although I'm doing a lot of talking right now. Point being though, as long as we just sit back and do more listening and less talking, I think we can solve a lot more problems a lot more quickly.
Okay. Rohit, question for you. AI, security, everything. Me, I am at the low level of the scale for AI. I'm a user Lambda. It's English to say Lambda, a basic user of AI. Yeah. Just a little bit before in the show, you were talking about the hack with AI. will it become more and more easy for people to hack companies or particular individuals, or will it be harder, or how do you see the market? How will it change the market of the hacking? I don't know how to call it.
Yeah,
but I hope you
I mean,
understood.
I think there's always with technology both sides of the coin, right? So firstly, you will see now that we are seeing a lot of security tools that are using AI. So, you know, any kind of current security tool that you might have in the past had, you know, alerts and a lot of, you know, review to figure out, is this really an attack, and how to triage that and figure out which ones are real alerts and which ones are not. Fraud detection, when I was at FICO detecting fraud, all of that has used AI. So we can expand the use of AI to actually catch these, you know, attacks that cyber criminals might launch. On the other side of it, cyber criminals will possibly be using more AI to come up with new attacks. So if you've kind of seen things like phishing, emails, they get better. You know, more websites can be created faster. People can fool you into thinking they're real when it's actually a bot you're talking to. So people have to be more cautious of, you know, what they divulge to various websites or interactions that they're having, because that may not be a real interaction. It may be a bot-driven interaction. And then there's the risks of AI in the fact that AI is still not deterministic. Well, the whole nature of AI is it's not deterministic. So you could be getting data from systems that you believe. Like I've had an example of, and obviously a little bit of trial here, not so much that they were going to depend on it. They asked ChatGPT to build them a vacation plan for Hawaii and to recommend hotels in Hawaii. And the first 2 hotels were very good. And the next 3 hotels were totally fabricated. They did not exist. They had very good information about them. They sounded very real, and really, they would have been my first choice to go to, except they didn't exist. So people have to be careful in taking information that they, like in websites, we always knew you had to go to reliable sources and validate. And I think with AI, people have to be even more cautious now in making sure like what they're seeing and what they're working with is actually real. It's not a hallucination. It's not factually incorrect. It's not made up facts. Made up facts is not a thing. I mean, it's not a fact if it's made up, right? So, so these are just some of the things that we see increasing, but I have full confidence, right? We will rise to the challenge. The younger generation will grow up knowing these risks and will deal with them, right? Like, and they will be able to sift through all of this. And then solutions like Tumeryk that we use to protect these models, to protect the interactions, they will become more widely used to make sure that, you know, people are not interacting with raw AI, as it were, right? That there were filters, fact checkers. So that's what we are building here at Tumeryk, is to essentially be able to guard your AI, both from invalid interactions and also from cyber criminals who can manipulate that AI.
Do you think it's harder or just hard to make people aware about this kind of risks compared to the other level, the other hackers of the old school hackers without AI, etc.? Let's say like this. Or I talk about make it people aware, the individual or even the company, to convince people that it's essential. Is it hard?
I think so. There's obviously, you know, the scale of the problem will certainly be bigger, because with AI, there's a lot more that can be generated content than there was possible with just humans, right? So there's a certain amount of, things that humans can do. But now with AI, you can automate and auto-generate a lot of content and make it seem it's real. So I think it will be harder for sure. But again, just as I said, like, as much as AI will be doing some harm to us, we will be using AI to help us reduce that harm. So we will be building more tools to be able to sift through data, to be able to give us some guidelines and be able to detect things that are false. So I think, it goes both way, and innovation always brings up some challenges initially, and then as civilization, we've always found ways to overcome it.
Right, question of adaptation. Yes.
Yeah.
Yep. So thank you, Jerome. I don't want to exclude you, Clay. So I got a question for you. Where does the idea of the FAS come from? Why didn't you use Open FAS, for instance? Why did you build it from scratch, or what is the history of the core of your product?
Yeah, so Rising Cloud originally came up to solve a problem that the company I was with at the time was having, right? We were having this issue where we saw many of our services and our workloads that we had made just sitting there not doing anything all the time, right? And some people might be like, oh, well, the solution is to grab somebody who understands how to use AWS or GCP infrastructure, right? And properly automate or handle with their autoscalers a way to manage these services that you're deploying, right? But the key there is for a smaller company or any company that operates independently with like different teams for managing infrastructure and development, you're not necessarily always going to have those people who manage infrastructure available, right? And the result is either somebody's going to have to spend a lot of time learning how to use these tools, which is time that they would better be spent, on their specialty, or you're going to have to eat a bunch of costs by doing a bad cloud configuration because you don't have the knowledge to do it as well, right? And those are like very real problems we were facing, and we were like, look, why instead of doing this, let's look and see if we like the tools that are out there. And if they don't solve the problem the way that we want it solved, let's see if we can build something that does it the way we want it done, right? And so we did a little bit of research, and we didn't like the available tools out there, right? There was a gap between what AWS and GCP offered and the biggest gap in other providers. The biggest gap we found was that they are hard to learn, right? Like right now, if you want to use them like really effectively, you need years of experience, right? And that's not always something you can have available for somebody that's a specialist. And we wanted to, reduce that gap. So we started there, right? The original inception came there. We built it from scratch. I remember it was just me at first. I built the initial iteration of this using a very different set of tools than we use now. And we've gone through quite a few iterations, as Sean was talking about earlier, the quote from Steve Jobs about people not always knowing what they want. I think this company has come a long way because at the beginning, I don't think we really understood what we wanted, right? We knew what the problem was, and we approached it in a very different way back then than we do now. And I think a big change we're making is to focus on ease of use, right? All the things you mentioned at the very beginning about like, oh yeah, we're faster, we're going to save you money not using as many services. Those are still part of this core of what the platform operates on, but a big push we're making is to make it easier to use, right? A big thing for me as a developer and any other developer is if I want to get something up and running quickly, I don't want to spend 1 to 2 weeks managing an AWS configuration just to figure out how to get my instance running, right? Or I don't want to hire somebody to do it for me, right? I've got my code working, it's running. Can I just see it, right? And so a big push we're doing is to make that process as easy as possible for all kinds of applications. Obviously, we've been talking a lot about AI, and that's our focus, right? Is to make it so that ML developers, I think, are very commonly not super knowledgeable in the infrastructure space. Not for any other reason than it's not always relevant for them, for researchers and the like, to spend a lot of time learning these tools, right? Wouldn't it be great if those developers could, push out their products quickly without needing a whole team dedicated to that management, right?
Yep.
That's it. That's where it originated and why we're, been slowly revising our mission statement to sort of target things that we see as more useful to people in the future.
Right. Thank you very much. Thank you. So I guess there won't be any certification for Rising Cloud usage or thing like that, unfortunately.
Absolutely not.
Not bad. This is it. And so while I'm with you, Clay, did the step to the DPU was complicated? Because where I have an issue with that is I know that you have to allocate some resource to be able to have a fast hot start with your instances, with your function. And if I take, I don't know, a ChatGPT or Ollama, which is the open source alternative to ChatGPT, the small model, I think it's 8 gigs of RAM. Or yes, I think it's 8 gig of RAM that you have to put in your GPU before to be able to run an inference. Is it not a challenge for you, Clay, to adapt your CPU to this kind of workload?
Yeah, so I'm not going to deny that it's a challenge, but I also think it might be worth talking a little bit about what the goal user is, right? Like who's going to get the most out of this? Because I think that might help answer, put in perspective what you're asking, right? There is a logistical problem to if somebody wants either fast response times or wants highly volatile workloads. There is a very legitimate technical problem associated with spinning up and down very high numbers of these GPU services, right? And unfortunately, some of those problems aren't ever going to be solved, but some of them we can do a very good job of essentially hiding all that back-end work from the user so that the user doesn't have to know that these things are happening, right?
Or to pay.
Sorry, go ahead. Oh,
Or to pay for
exactly. Yeah.
this process.
And Sean was mentioning earlier, and I think this is also another good thing to talk about. There's a lot of research and development going into allowing these really large models to run on CPUs comparably to GPUs. And we're doing a lot of internal research and finding tools that we like to fill that gap as well, because a lot of the big technical problems that you might anticipate and correctly anticipate with GPUs are solved if you can find a way to essentially sparsify the model. There's a bunch of different ways to do this to allow them to operate at similar capacities with minimal loss to performance, right? So we're exploring all of those. There's a bunch of discussion and there's a lot of new tools coming out to allow GPUs to be split, right? And that'll allow you to basically have multiple people using the GPU at the same time. So from a client's perspective, they can have multiple instances of their same workload running on a GPU, right? Which makes it a lot easier for us to deploy at scale and scale up and down without having to reserve a single GPU for every single customer or for every single worker that's operating on our platform, right?
Yep.
We could be here for an hour if I were to talk about all the technical challenge, but I guess to suffice it to say, you're right, and it's not an easy problem. But again, that's the point of what we're trying to provide is to make it so that as a user, I don't even have to worry about that. I just say, hey, I want this to run on GPU, and this is how big it is. Can you handle that for me? And the answer is right. And there's some downsides, some upsides, and maybe if we want later, we can talk a little bit more about what those are compared to operating it yourself, right? Like if I were operating it myself, I would maybe just spin up the service and leave it running so that I could always have the model loaded right there. That's pretty expensive, right? But I'm going to get really fast response times, right? And there's a trade-off between doing that and allowing scaling to happen automatically, because now you have a little bit more latency to spin up and down the service, assuming that you're doing it really sporadically, right? Sean was talking about the use case we have right now where a customer is spinning up like 200 at once, right? They're doing batch processing. In that case, they don't see any effects and only see the benefits, right? Because they're sending tens of thousands of jobs all at once to get processed, which means our servers can just stay up and everything's already loaded on your GPU. That initial uptick of time or latency time that happens on that very first request doesn't matter, because over time you're running hundreds of thousands and you're getting that response time you want for every other one, right?
Yep. Okay. Thank you very much. Thank you, Clay. You mentioned several times that the pricing will be lower. I guess firstly it will be lower because I can fit exactly with my function in terms of of resources. And also you get an AI to optimize the cost of my function. But if we look at the market leaders, generally they announce the price in dollar per microsecond, something like that. If you make this pricing in hour scale and you compare that with VMs, you're gonna cry just. But I know that at Rising Cloud you get a lower price. I don't know if it's microsecond, maybe it's nanoseconds, but I know that you get a lower price than the hyperscaler. But how do you do that, or why do they charge so much for the same kind of?
Well, I mean, I think the why is a great question. I mean, you look at the profit, just looking at their financial reports, and you can see why they're charging so much, because they can, and they're very profitable in charging that. We took a different approach, and we're focused on helping our customers grow. We even have a startup initiative where companies can actually apply to get credits for 3 years for us, unlike the other hyperscalers are usually just 12 months of credit. So, we know that it's hard to be a startup, and we're here to support them. And so one of those ways we support them is keeping our costs down and not charging as large of a profit margin as our competitors do. So that's, just first and foremost, that's what we do to begin with. After that, though, as Clay talked about, we're using the algorithms to figure out when you need and what you need and how you need it so that we can keep that overall cost down. And then the third piece is I realize it's an intangible measurement, but it is that productivity piece. At the end of the day, you have a developer who either is tasked with building the actual application that you want to run, or setting it up, configuring it, and managing it and running it for you in a cloud platform. And when you take time away from building the application and focusing on the running part of it, you're taking time away from that developer, and that has a cost to you. That has an opportunity cost that's lost because they can't focus on the feature that they needed to build or the functionality they needed to add to be able to address your in pain point. So when you couple those three together, that's how we can overall be more cost effective for companies than the other hyperscalers.
Okay, and in terms of usage, I guess that you have it's heterogeneous. You get plenty of kinds of usage, plenty of types of workloads. But I'm wondering if there is something that is drawing. For example, because people get out from AWS, they think, oh, now I should boot a function with a 64 CPU. Or do they try to get the minimum things? Or is there a pattern that comes from the people that used to use Lambda or things like that?
Yeah, I'd say the common pattern actually is just people's reticence to trust the AI. Inherently, we don't think that the computer is going to be able to do what it claims to do, because generally speaking, it's not, even talk about hallucination, things like that it still happens. But that's really generally the pattern we see, is people will start off by controlling the algorithms. I want this amount of CPU, or I want this amount of RAM, or trying to force it to be like the other hyperscalers, and not taking that step back to say, what am I trying to actually do, instead of what do I need? What do I want to do? And so when they take a step back and say, okay, let me peel the layers of this onion that I've added on to make it run in a hyperscaler, peel those layers back to the core application, and then think about, okay, I don't really need to tell the system how much CPU or how much RAM, or you do have to tell us, what type of GPU you want, for example. But besides that, I just let the system do what it needs to do. Build the load balancers for me, provision DNS for me, manage the actual traffic to the applications, manage the spin up of the workers and things like that. When they take a step back from trying to control that and just let it do what it needs to do, that's the pattern we usually see. Everyone wants to control until they trust, and that's fine. Absolutely, everybody always trust but verify concept goes back to security. Rohit and I, back in the day, that was a thing. But the end of the day, that's kind of the pattern we see, is people try to control until they realize it can do what we say it can do, and then they start letting it do what it needs to do, and focus back on building their applications and not worrying about how those applications are running.
Okay, so clearly it's a matter of maturity versus an AI, and think, oh, Sean really told me something true. I could just let him be in charge of my function. um, Excuse me. About the technology, do you use VMs, containers, bare metal,
Nope.
or?
Yeah. Well, it's twofold. So we do not use VMs at all. We are all containerized, even the functions, for example. But those containers then run on bare metal. So from a customer perspective, if you're giving us a function, it looks and feels like it's on bare metal, but it's actually running in a container. So we're using the container model for security and the benefits of the scalability, but at the end of the day, performance is still on par with bare metal performance. So there is no hypervisor layer. It is just container running on bare metal that is allocated to your worker for the period of time you need it for.
Yeah, and I actually want to talk about a roadmap item a little bit here because I think it'll add a little more color to what we're doing, right? What Sean said is totally correct right now. And what we're sort of moving to and wanting to do in the long run is allow people to sort of bring their own infrastructure over to our service, right? And that can be a managed provider that already exists, i.e. they can be like, oh, I want this on my AWS account, right? Cool. They allow us to manage that infrastructure for them. Or it could even be local services, right? Or you've got a local machine that you want to be part of this cloud. Cool, register it with us and we'll be able to do it there too, right? So at the end of the answer right now is exactly as Sean said, but at the end of the day, there's really not supposed to be a restriction to this, right? The whole point of the platform is to make it as easy to use as possible. So if you're, whatever provider you might be using, we want to be able to integrate with it so that you can just say, okay, well, I'm using this, I don't want to set anything up. Here it is, and we'll just manage it for you, right? So if you use VMs for whatever reason, cool, whatever. We can use that for you as well, right? That's the end goal, is to make it as easy a process as possible. Because again, a big focus of us moving forward is to ease developers into the process so that people don't have to spend years getting certified and understanding how these big providers work, right?
Yep. Thank you very much, Clay. Jerome, do you have any question on your bag?
I have one question. Once again, it's more a large question. Like this, it's really hard. I guess for technician, it's harder to answer a global question. I don't know actually. But this question is more for everyone actually. Here, what will be the next challenges for the clouds in the next years for the clients and for the providers?
If I can answer first, I got an idea in my mind, but it's making money out of a GPU because the NVIDIA pricing is going higher and higher. But it's just my answer.
Question of price again.
Yeah, I think I would couple on to that. It's making money out of the AI while at the same time not spending money to make that money. Obviously there are a lot of benefits that can come from new technology and new tools, because at the end of the day, this is just a new tool, new technology. But being able to adopt that new technology and have that technology adoption turn into revenue instead of just cost, that I think is going to be the key pendulum of making sure that we're still profitable from this new money that we're bringing in. I don't want to be spending 500 million to make $30,000, for example. I saw a meme the other day of an OpenAI bill, and that was kind of along the lines of it. But I think that's going to be the key, is to be able to utilize it in such a way that it does add both benefit to the user, but at the same time also revenue to the company without an offset cost that is more than the revenue coming in.
Yeah, I mean, I agree with all of that. I'm going to add a different item that I think I might be slightly worried about, or just a comment on sort of cloud providers in general as they progress. I think it's going to be similar to some of like old legacy code and how it operates now, where if you want to find a COBOL developer or something like that, right? They're in super high demand because it's not taught anymore. It's sort of a legacy thing, right? And I see, without more providers doing what we're trying to do, I see a similar thing happening to the provider space, where it is going to be very difficult to find people who know how to operate AWS. And the reason I'm saying this is because we've consistently seen them add more and more features and more complexity over the years, and it's getting harder and harder to learn how to use that system. And it's not really through direct fault of their own, right? They're trying to provide more services and make sure that they're a more complete platform. But as you do that, you end up alienating people essentially. And at a certain point, I see a very probable outcome being the only people who know how to use these big providers, assuming they don't do anything about it, are going to be the people who learned it 20 years ago, right? And I think that's something that needs to be kept in mind. I think that's a big reason why I'm pushing this direction with Rising Cloud so much, because I think that's an important thing that cloud providers need to keep in mind if they're going to keep, operating the way they are.
By the
I
way,
think what you
sorry.
just heard there is Clay's making the prediction that the cloud is the new mainframe. I think that's a very interesting point. I had not thought about it that way, but that is what he's just said, is that, you've got the mainframes of yesteryear, which are still supporting plenty of things, banks and ATMs and things like that. But at the end of the day, it's just infrastructure to end goal of providing a service. And the cloud is just infrastructure. And that's the future of it. I think Clay just summarized it perfectly. Like, I got a little poof, went off in my head when he said that.
About the complexity of things, you were talking about AWS that has plenty of services, etc. There is a topic we especially, with Anthony, we talk often. It's the certification. What certifications? What is your opinion about it, about the certification and the market of certifications, if we can call it like this?
I might need you to reword that just to make sure I understand what you're asking, so I don't go off on a tangent here. Yeah, could you reword that real quick for me?
There is a kind of we see it also actually on LinkedIn about the certification, AWS certification, Azure certification, Google, etc., etc. There is business almost of certification trainings, etc. And there is now we talk a lot about the simplicity and the complexities of the providers. Lately, it sounds like you need to prove you are capable to use a product with a certification as a kind of proof of trust to show that you are trustful.
Like a diploma.
Yeah.
Like a diploma, exactly. What do you think about this? Is it a symptoms that show that everything got too much complex? Is it too much business thing?
No, so I think this is a natural progression of things, right? As a product, in this case, I'm just going to call it the cloud as the product I'm talking about in general. As it progresses, there become more use cases and there becomes more need as it becomes more widely adopted. So it's a perfectly natural progression for these services to get more and more complicated, right? And so I think, as you're describing this sort of need for people to be certified and, you need to proof out that people understand these. I think right now we're at, I think, is a healthy-ish place, but it's trending downwards, right? As the tool gets more complicated without the desire to make it accessible, right? And that's what I'm seeing right now, because companies already have the people that know how to do it. So, these big providers aren't going to invest money making it more available right now, because they don't need to, because everybody who uses their platform already knows how to use it, right? And at a certain point, those people aren't going to be in the workforce anymore, right? I don't know if that directly answered your question, but I mean, you're right that, people right now, you need some level of understanding, and a lot of companies won't, if you're doing anything that require, like if my stack includes GCP, a lot of companies will be like, oh, you don't know GCP? Sorry, we can't bring you on, right? Like, it is very much a filter now for people.
Yes.
Right? Which is crazy, because I just recently was doing a little bit of work where I had to work with GCP, and I feel like I spent like 2 months learning the particular stack, right? And I'm sitting here like I barely wrote any code. Most of my time was learning how this product works, right? And I think that's not a healthy place to be in the long run.
Okay.
Very true.
Thanks.
I've got another thing like this. A few months ago, maybe more than that, 5 or 6 months ago, there was this news, the team from Amazon Prime, the video platform, said that they will not stop, but they will reduce drastically their usage of Lambda to go to EC2, because how they use Lambda, okay, they can scale infinitely, but their wallet cannot scale infinitely, and so they just prefer to define a static fee from the long-term usage from AWS EC2 than using the modern Lambda service. What do you think about it, Clay or excuse me,
Yeah, no, I can talk to it.
or Rohit?
Go ahead, Rohit.
Yeah, well, we actually, I will say, when we started building our product, Tumeryk, we do adversarial attacks, and we initially started out with Lambda as well, and then very quickly found that, it's good to obviously get started with it, but once you have sustained loads, it's not really the right tool for us, and so we decided to containerize the application and essentially run it more statically from an infrastructure perspective because of the warm-up times that were involved in getting your Lambda function to work. And, it was like if you needed to actually get something going and the warm-up was consuming most of the cycles as opposed to the amount of compute that you were actually going to consume, it wasn't making any sense. And so if you have sustained loads, it doesn't make sense in those types of situations to use Lambda. Lambda, we found useful, a lot of times where, and I'll give an example of a previous company where we were actually running these large fraud models, detecting fraud using AI on Lambda again. And essentially when the clients were sending, say, 10 requests, like, how different types of transaction volumes will come. So sometimes you'll see 10 transactions a day. For some applications, you might see millions of transactions a day. And if it's 10 transactions a day and the latency requirements are not that high, then it's okay to use Lambda because then you're saving a lot in cost. But when you actually have millions of transactions a day, then it doesn't help to actually run Lambda. The only thing you have to do is essentially, in fact, we had something we called Lambda warmers. So we had a process that would keep our Lambda warm all the time, which almost defeats the purpose of having Lambda. So I think based on the use case, you have to kind of decide what makes sense for you. So there is probably a use case for Lambda, but I think as things scale up beyond a point, then it doesn't make sense to use Lambda. And at that point, you're just better off getting a full container.
Okay, and
Yeah, I
so
think,
go ahead.
I was just going to
Shannon.
add a couple onto that. Yeah, exactly as Rohit said. I mean, I don't, not everything is a nail, not everything's a hammer. So it's, as with any technology solution, you have to look at your use case, your volumes, and determine what are the right technologies and architectures to use to address what your use case is. I will add though, obviously we are designed differently than Lambda. So I'd be happy for the Prime Video team to come over and take a look at Rising Cloud, because we'd be happy to show how we compare to Lambda, and we'd be happy to, bring them on our platform because we know we can scale out to support their needs at a lower price point than what Amazon can do.
Yep, sure. You got two valid point, which is a lower price. So if the price was the first problem for them, you got lower price, and then you can adapt and fit exactly with their requirement. So it's not the same case. We can compare Lambda and Rising Cloud, but not directly or not without some gloves. That's very true. But to come back to your comment, Rohit, when you say a sustain workload, I imagine that, for instance, you get I don't know 1,000 requests per minute, or let's say per second. At this moment, it's not in terms of price. Firstly, it's not useful to use Lambda because you will pay for each request. When if you have a server, you will just pay for your server. Okay, this is exactly what you mean. Exactly, this is what I was thinking, and I'm thinking about doing a benchmark one day about this. Where is exactly the point where you should use a VM rather than Lambda? But
And it's also a quality of service issue as well, right? Because when, as I said, latency on a cold Lambda can be an issue. So think of a situation where I'm trying to do a credit card transaction validation, right? That requires me to do it in seconds, but it may not come for a long time. So let's say it's a low volume kind of situation, then you kind of have a situation where essentially the request comes intermittently, but every request takes a long time to service because you have to go through the whole cycle of a starting of a Lambda and, you know, just getting that up and going, right? So you can't meet the service level for latency. While you can scale, you may not meet the latency. So there are both sides of it, right? Throughput and latency. And the latency sometimes can be a problem with using Lambda. So again, like Sean said, there are different use cases. Sometimes it works beautifully. It's certainly very simple to use. And I think having the best of both worlds with Rising Cloud is really the key here, right? And people can take advantage of their architecture to match both the latency requirements and the scale requirements.
Right. Thank you very much, Rohit. Thank you. Let's make 1 hour and more we are talking. I've got 2 last questions. Maybe, Jérôme, you get another one. If you get one, I let you begin.
No, it's okay, you can ask.
Okay. It's about GPU and AI. I guess Rising Cloud is perfect for the inference because inference is asking the model something, so it's perfect. When I use Rising Cloud with my model, it transforms it directly in a SaaS application, I would say. Anyone can use it directly. But for the training, does Rising Cloud is match with this kind of workload? If I would like to train an AI, let's say I would like to train my AI, and I've got a fleet of mobiles that send image that my AI should learn to detect.
So it absolutely does. A big push that I was talking about roadmap and goals I'm trying to do is to make this process easier to integrate with, like easier for people to use, but it exists, works fine now, and is actually a very good use case for us, right? There are some caveats, and I don't want to go into all of them, but in general, you know, if you want a access to a large GPU so that you can train your service in a reasonable amount of time, we absolutely support that, and it's a very good use case, right? A lot of the long-term things I'm looking for is to make it easier to even specify that you want to do this training. Oh, I want to use an existing data set or a custom data set, either or, with an existing or a custom model, and I want to fine-tune it with that combo, right? I want to make that as easy as possible for anybody coming to our platform so that they can just specify, here's my model, here's my data set. This can either be custom or public, and that they basically press go and it will automatically set up their training and deployment of their inference model for them, right? Wouldn't that be great as an ML developer so that I don't have to focus on any of the rest of it, right? So yes, we absolutely support that, and I'm looking to create a lot more of these tools in the future to make it even more accessible.
Okay, thank you. And Shen, you mentioned about AI working on CPU. I guess you met my friend from Neural Magic, which are doing sparsifying of a large model to run it on GPU. And so, do you plan to do something like a marketplace of function that you can directly use, AI that you can directly use on Rising Cloud from 2 buttons, from 2 clicks?
Yep, absolutely. So the point behind what we're planning for next year is not only making the product that we have easier for people to be able to run that AI, but bringing in the thought leadership and technology leadership that's out there from companies like Tumeryk, possibly from Neural Magic, for example. All those technologies that, when added on top of the core that you're running on our platform, make us 2 + 2 = 6. And not just 2 technologies that you have to use independently. So that's exactly what we're planning to do, is bringing in those like-minded technologies that are out there that just can complement and make us all better at the end.
Okay, thank you. I had a good guess. Jerome, do you have a last question?
It's okay for me.
Okay, cool.
Everything is okay and clear.
So last thing I would like to ask is if you got any words to let to our audio video spectators. I begin by you, Rohit. if you would like to say to anyone, go to Tumeryk, you can. There is no issue.
Yeah, well, I mean, I would certainly encourage them to innovate with AI first. And then as you innovate with AI, think of the risks and we'll help you mitigate those. So check out tumeryk.com, right? But don't let the innovation stop.
Thank you. Clayton, do you have a word?
Yeah, I'll just say I'm doing my best to look out for people like me 6 years ago, where I wrote a whole lot of code. As Sean said, I was studying like dark matter and stuff in school. I was an astrophysicist, and like I wrote a bunch of code, and I had a bunch of stuff that I wanted to be able to run, and I didn't know anything about clouds, right? And I want to, he's talking about first and second wave. I think probably the third wave of people that I want to reach are people like me, old me anyway, so that they have access to these tools that I didn't without having to go through the last decade of learning, right? So I'm looking out for you is what I want to say.
Sven, do you have a word?
Yeah, no, I mean, just coupling on what Rohit and Clay said, to use it's just a technology in the day. This is just a new tool, another tool in our tool belt that we have as humans to be able to, use. And obviously tools can be used for good or for bad. So, think about how that tool is being used and focus it on helping the world for good. And that's at the end of the day, the only thing I can ask for. Appreciate you having us on. Appreciate you all taking the time to listen to us. Definitely happy to jump on anytime you want, Jerome and Anthony. Really appreciate it.
Thank you. Thank you. Thank you 1,000 times. As a last word for my part, I will just have to say, come to follow us on YouTube, on LinkedIn, on the different social networks, like usual, not on Twitter. Twitter, it's personal, it's useless to come. I say it because a lot of people come to my Twitter and see I just look at MMA and things like that, so it's not useful. So yes, come to follow us on our different social network. And thank you guys, thank you sirs for all this answer to our questions. Have a good day.
You're welcome. Thanks for having us on.